Okay, so far we learned about how to get those center of mass locations using the brief definition of torque. And those are our equations, but that's x, y, and z, right? In again reality, the individual masses are likely to be distributed through a 3D space, not just on a single line. And we can combine all three of the above results into a vector form because we know that R is the three-dimensional position vector. So just like x center of mass, that's the center of mass of the x position. R is going to be the center of mass, the position of the center of mass, okay? So, and here we have a couple other things. I'm going to talk about what they are first, and we'll think about the figure here. Again, R sub cm, that's the center of mass, is a vector that points from the origin to the center of mass of the object. And that is shown as blue vector here on the figure. And that blue m is not the mass, physical mass. That just says you have m1, m2, and m3. This is the distribution, but they are actually can be condensed at that position, our center of mass, as capital M. And capital M is simply m1 plus m2 plus m3. Okay, that's the total mass. So again, this center of mass location doesn't have to be on the objects that we have. And this is the point that we are looking for to solve, okay? And Ri in the equation, so we have this equation here. So we just really replaced x or y or z with r, and then we made the vector r. So instead of components, we have the entire vector now, which kind of contains all those informations for x, y, and z, because we know that r is written as x1, like r, if it's r1 it is, then x1 I had, and plus y1 j had, and plus z1 k had. So those i's here, the indices I, from starting from 1 to n, goes to n, is really just a position vector that points from the origin to the center of mass for the ith object, okay? So you have three masses. So in this case, I goes from 1 to 3. And similarly, we can also write R2 and R3 to this equation. And then the center of mass R can also be written similar format as the unit vector notation. Okay, so most objects are not blobs of masses, so this is not very realistic. However, we saw that earlier that many items can be treated as particles, and we'll use this to our advantage. And also for many objects, the location of center of mass is known because they are very nice geometry or symmetry. So for example, where do you think the center of mass for a homogeneous square plate measuring 6 inch by 6 inch by 1 inch is?